So we're going back to like elementary school long division. So a few keywords here. This number out in front, this is known as our divisor. That's an R at the end. That's our number we're dividing by. This number here is our dividend. That's our number that's being divided. So let's see who remembers how to divide by long division. So since this is a 2-digit number out here, we look at the first 2 digits underneath the division sign. How many times can 17 go into 26? Once. So I put my 1 up top. 1 times 17 gives me a 17. And then we got to subtract it. So 26 minus 7 gives us what? 9. And then you got to bring down your 8. So it gives us 98. So now we have to look at the 98 and figure out how many times can 17 go into 98. Because 17 went into 26 one time. 5?
7 times.
So I put my 5 up here. 5 times 17 gives me an 85. So I subtract my 85 and I get a 13. What do we call the 13? No. Remainder. So remember how you would put like a little R and then you'd write whatever your little remainder was afterwards? Yeah. This up here is what we call our quotient. So that's basically like our answer when we're dealing with a division problem. So then if you're taking these numbers, the way you would check it to see if you did it correctly is you would do 17 times the 17 times the 15. What do we get? You use your little calculator to help you. 17 times 15. 255. And then add our remainder to it gives us what? Which is exactly what we started with, so that means we did it correctly. So our answer would be 15 remainder 13. So that's our little elementary school days. So we're going to step it up a notch because we can't be in elementary school anymore. We all grow up a little bit. So a couple of little things to keep in mind here, and I will keep going over it throughout the notes today to try to get it to sink into your mind. If the remainder is a 0, we then say the divisor goes into the dividend evenly, or we say that the divisor is a factor. Now it didn't go in evenly up above, we had a remainder, but if it does go in evenly you would get a 0, so we could call it a factor because it goes in evenly to it. Alright, so our first problem here for our long division with our polynomials, it's set up the same way. We would use all the same terms. This x plus 6 out here, this would be our divisor. This down here is our dividend. We're going to try to get our quotient. So what you have to do is you look just at your x out in front, and then you look at your first term underneath the division sign. And you have to ask yourself, how do I make an x into a 2x squared? What would we multiply it times? 2x. So I put my 2x up top. That's going to be part of my quotient. And then we need to multiply 2x times the x gives us 2x squared. And then we also have to do the 2x times the 6. So that would give us a 12x. So we're doing the same steps we did up above, it's just you had 2 things you had to multiply it times this time. So we're going to take that and subtract it. I always put it in parentheses when I subtract, because you got to remember, you got to subtract both terms there. So 2x squared minus 2x squared, those cancel just like we wanted them to. This 12x is now a subtraction, so 15x minus 12x gives us a 3x. And we bring down our 20, just like we brought down our 8 before in the other example. So now we're going to deal with 3x plus 20. What do I have to multiply x times to make it a 3x? 3. So I put my plus 3 up here. So 3 times x gives me 3x. 3 times 6 gives me a plus 18. So we got to subtract that. So our x's cancel. This 18 becomes negative, so 20 minus 18 gives us a 2. And there's no way to make a 6 into a 2, so that's where we stop. So we have a remainder of 2. Now the way we write our answer with our polynomials is we start with our quotient up above, so it would be 2x plus 3. We don't write the little r anymore. The way we write our remainder this time is it's 2 over x plus 6, 2 over whatever your divisor is. And that would be our final answer for that. Now again, if you were told to check it, the way we would do that is you would have to multiply your divisor times your quotient. And then you would add your remainder, and kind of like we did above, we multiplied our 17 and our 15, and then we added in our remainder. So let's just multiply this out. X times 2x will give us our 2x squared. X times 3 gives us our 3x. And then 6 times 2x gives us 12x. 6 times 3 gives us an 18. And then we still have our plus 2 from our remainder. So when we combine all of our like terms, like our x's and then our numbers, we would have 2x squared plus 15x plus 20, which is what our dividend was, so we did it correctly. They're not going to ask you to check every single time, but if in the event that they do, that's how you would do your check. Multiply them out, add in whatever your remainder was. This stuff right here, that's just telling you how to write your answer, which is what we did. The q of x, that represents your quotient. Your r is your remainder. And the x minus a is your divisor. So on the Regents exam, they've used that notation. They told you to divide these two polynomials and write your answer in this form. So just so you get used to what that form is, that means we're just writing it like this. You're writing your answer, and then you're writing your fraction for your remainder. All right, so let's try another one. Divisor out front. What we're dividing by goes underneath your division sign. So again, we're going to look at the first terms. How do I make an x into an x squared? Times it by x. So I put my x up top. X times x is x squared. X times negative 3 gives me a negative 3x. So we got to subtract that. So when we subtract, what happens to our x squareds? Cancel. My 3x here turns to what? Positive, because again I was subtracting. So 2x plus 3x gives me a 5x. And then we got to bring down our minus 5, so we have 5x minus 5 now. What times x is going to give us a negative 5x? 5, so plus 5 up there. 5 times x is 5x. 5 times negative 3 is negative 15. So we subtract them. Our x's cancel. That 15 turns to positive when I subtract. So negative 5 plus 15, we get a remainder of 10. So whenever you get down to just a single number, that's as far as you're going to go. So again, we would write our answer here as x plus 5 plus 10 over x minus 3. That's our quotient with our remainder. How are we doing with this so far? You guys are kind of unusually quiet. Well, at least I'm usually getting a little bit of feedback. Getting nothing. So again, divisor goes out in front, so our x minus 10 is out in front of our division sign. Then we put our dividend underneath, our 2x squared minus 23x plus 17. So what times x gives us a 2x squared? 2x. So 2x times x is 2x squared. 2x times negative 10 is a negative 20x. So we got to subtract them. So 2x squared and 2x squared, those are going to cancel when I subtract. My negative 20 turns to what? Positive 20. So negative 23 plus 20, negative 3x plus our 17. So now x times what gives us negative 3x? Negative 3. So negative 3 times x is negative 3x. Negative 3 times negative 10, positive 30. So when we subtract them, what happens with our x's? Cancel. This 30 becomes negative, so 17 minus 30 would give us a negative 13. So our answer would be 2x minus 3 minus 13 over x minus 10. Since your remainder was negative, that means you subtract it from your quotient. All right, so I want you to try the third one on there. Yes, I know it's a little bit longer, but it's still the same steps. I want you guys to try that one. So that one, I always put a smiley face when we don't have a remainder. It's something my math teacher always made me do, so it's a habit you just can't break after this many years. So this one has no remainder. This one divided out evenly. So our answer would simply be x squared plus 2x plus 7. But then the other thing is that it was telling us up above is that x plus 5, that is a factor of our original polynomial that we had there since the remainder is 0. That's something that we can tell by the remainder being a 0. Our other factor of it would be your x squared plus 2x plus 7. Yeah, smiley face is pretty fun. Now, to touch base a little bit on this note down here, if you are missing a term in your polynomial, you have to put a 0 placeholder. So what that means is I put this example up here on a different page. I had x cubed plus x minus 5, and I was dividing by x minus 1, but it was missing the x squared term. So when you put it under there, you still have to put 0x squared. You need to have that placeholder there so that you actually do your division correctly. If you don't put that there, you're going to end up doing your division incorrectly. So if it's missing a term, you've got to put a 0 placeholder in there. Capiche? Capiche. All right. Let's go on the back here. This one's my favorite. I love synthetic division. Woo, synthetic division, little smiley face. Woohoo! The reason why I love synthetic division so much is because it's a shortcut for long division. So it doesn't take as long. I love it. So, a couple of things you have to remember. If x minus a is a factor, then x equals a is a 0. Again, I will go over that information as we get into some examples. That's when it makes a little bit more sense. So when we're doing synthetic division, first thing we have to do is solve the divisor for x. So if we take a look at our example up here, my divisor is my x plus 6. So what I'm going to do is I'm going to set that equal to 0. When it's set equal to 0, what would our x equal? Negative 6. We would subtract our 6 over. So there we go. That's my first step. So our second step is you are going to use simply the coefficients of your dividend here. So use only coefficients of dividend. So we create a little box, and that's where our negative 6 goes that we just found. That doesn't disappear, that's still there. So we got a little box with our negative 6. Next to the box, we're going to put the coefficients of our polynomial. Now again, if it's missing a term, I have to put a 0 in that spot for that term. This one's not missing any though. It goes x squared, x to the first, and then our number. So I'm going to put my 2, my 15, and my 20. We're only going to use the coefficients. And then you want a little bit of space, and then we can put a straight line there. Trust me, you're going to love it. You're going to be like, oh my God, Mrs. Pelkey, why can't I do this all the time? So step 3, you always just bring down your first term. So here, we just bring down my 2. First one always just gets brought down. Move this up a little bit. Step 4, you're going to multiply by divisor, then add down. And we repeat step 4 lots of times. Well, however many times we need to. So what I mean by multiply by divisor, then add down, I'm going to take my 2, multiply it times my negative 6 here in the box. That gives me a negative 12, so I line it up under my next coefficient. And then we add down. So 15 plus a negative 12 gives us a positive 3. And then I repeat that step again. 3 times negative 6 gives me a negative 18. Add down 20 plus a negative 18 gives me a 2. Now, since we were dividing originally up here with something that has x to the first term, when you write your final answer, your exponents are always down by 1. So since this started as an x squared, when I write my answer, this is just going to be 2x to the first. That's going to be a plus 3. And then 2 is our remainder, so it's 2 over x plus 6. This last one is always your remainder. Then it would start as 2x squared. Yep. And that is the same exact first problem we did on the front, just we did it with a different kind of division, which I think goes a little bit faster. All right, let's try this one again. So our divisor is x minus 4, so I'm going to first set that equal to 0. So our x would be a what? 4. So I put my little 4 there in the box. That's our divisor. Are we missing any terms in our other polynomial there? No, they go in order. We got squared to the first and then a 0. So I'm going to put 5, negative 17, negative 12. And put a little space underneath them and then my line. So again, our first term, we just bring that down. So we bring down our 5. And then we do 5 times the 4 gives us 20. So then negative 17 plus 20 is 3. So then 3 times 4. And then negative 12 plus 12 is So again, this one has no remainder because that last number there in your synthetic division is a 0. So there's no remainder here. So this started again as an x squared. So when I write my answer, it drops down 1. So this is 5x plus 3. Well, unless it tells you specifically you have to use long division, which sometimes that does show up. But if it doesn't say how to divide, you can always use synthetic division. Yeah. So again, since our remainder here was a 0, something we know is that x minus 4 is a factor of that polynomial, again, because the remainder is 0. And that one right there is our answer. All right, let's try example 3. So again, first thing, take our divisor, set it equal to 0. So x minus 2 equals 0. What would our x equal? 2. So I'm going to put my little box with my 2. This one's missing a term. Which term is it missing? That's not the one it's missing. It's missing the x cubed. So I'm going to start with my 3 for my x to the 4th. I got to put a 0 in there for my x cubed. Then my negative 8, negative 11, and 1. If you forget to put that placeholder in there, you're going to get the problem wrong. You got to always remember to look to see if all of your terms are there. So we're going to bring down our 3. 3 times 2 gives us 6. And then 0 plus 6 is 6. And then 6 times 2 is 12. Negative 8 plus 12 is 4. 4 times 2. And then negative 11 plus 8. Then negative 3 times 2 is, so we got a remainder this time of negative 5. So again, this started as x to the 4th. So for our answer, we drop it down 1. So it's going to be x cubed plus 6x squared plus 4x minus 3 minus 5 over x minus 2. See, didn't I tell you synthetic division? Awesome. Love it. All right, so example 4, it says p of x is that polynomial there, and x plus 1 is a factor. They want us to find the other two factors. So what we need to do first is use our synthetic division, get it down to an x squared, so it's a quadratic, and then we can factor it. So x plus 1 equals 0, so our x is a what? Negative 1. Is our polynomial missing any terms? Nope. So we're going to have a 1, a negative 4, a 1, and a 6. So again, I bring down my 1. 1 times negative 1 gives us negative 1, but when I add it, I get negative 5. Negative 5 times negative 1. And then 1 plus 5 is? And then 6 times negative 1. So we get a 0, which we already anticipated we were going to get a 0 because they told us that x plus 1 is in fact a factor. So we knew our remainder there was going to be a 0. So that means our quadratic that we're left with is x squared minus 5x plus 6, which we can now factor. Will our signs be same or different? The same. They're both going to be negative. So what multiplies to 6 but will add to give us a 5? 3 and 2. So there's our other two factors. X minus 3 is one of them. X minus 2 is our other factor. There we go. All right. And then our last thing here is our remainder theorem. We've kind of already been talking a little bit about it. If you get a remainder of 0, that means whatever you were dividing by is in fact a factor. So what it's also saying is once you get it equal to x equals a, like we were doing for our synthetic division, that a value and whatever your remainder is becomes a point on the graph. So what that means is if I take a look back here at one of our other problems, like if we look at this one for a second, this would be our a value because that's what x equals. This was our remainder, so on our graph it would hit the point to -5. So whatever that is with your remainder, that's going to be a point on your graph. Other things our remainder theorem tells us. If our remainder is 0, then whatever we divided by is a 0 or root of the polynomial, which we already knew. If the remainder is 0, you can also call it an x-intercept, which, as we know, is just another way of saying your roots or your zeros. And then if your remainder is 0, then whatever you divided by is a factor of your polynomial. So those are all things we've already been talking about. This just kind of puts it back together again. So if they're asking you, is x minus 3 a factor of that polynomial? There's 3 ways we can figure out the answer to that. One way would be what we did on the first page, is by using your long division. When you use your long division, what would your remainder have to be in order for it to be a factor? 0. So if you get a remainder of 0, then yes, it is a factor. The second way we can do it is what we were just doing on our last page of synthetic division. And again, if your remainder is a 0, then yes, it is a factor. Now the third way we can find out if it is a factor is take your x minus 3, kind of like we would for our synthetic division, and set it equal to 0. What would our x be? 3. So then just take that 3 and plug it into your polynomial for your x values. And then let's see what number we get. So 3 cubed, what does that give us? 27. 7 times 3? And then minus our 6. So what's 27 minus 21 minus 6? 0. So yes, it was a factor. That's our other way we can tell. That's our remainder theorem right there. So because of this remainder theorem, the things that we can tell is x minus 3 is a factor of that polynomial. We can also tell that 3, 0 is an x-intercept. There it is. X equals 3 is a root or 0. And then the last thing we know is that j of 3 equals 0. If we plug that value in, we get a 0. So those are the 4 conclusions we can draw. So now your synthetic division and your long division, you have to use those when they tell you to divide the whole thing out to get your quotient. If all that they want is the remainder, like this one, just simply find the remainder, then all we have to do is like that last one we did up above. We just have to plug the value in, and then we can find our remainder that way. So take our x minus 3, set it equal to 0. and we would get x equals 3. So now all we have to do is plug 3 in for our x's, and that'll tell us what our remainder is. So 3 cubed minus 2 times 3 squared minus 4 times 3 plus 5. So again, that gives us 27. 3 squared is 9 times our 2 gives us an 18. 4 times 3 gives us a minus 12, and then plus 5. So what do we get when we do 27 minus 18 minus 12 plus 5? 2. So our remainder is 2. Now again, if they're asking for just the remainder, all they want is the number. The only time you make it the fraction is when they're asking you for the quotient. Then you have to put the remainder over the fraction. But if they're asking purely for the remainder, all they want is that number right there. The other thing that happens, again, the point 3 comma 2 would be on your graph if you had to graph this polynomial. That's the other thing we can tell from that remainder. So let's try a couple more examples. So example 3, again, all they want is the remainder. Find the remainder when this is divided by x minus 1. So first set that equal to 0. X equals what? 1. So all we have to do is plug in our 1 for our x. Which I'm very thankful it was a 1, because I don't want to do any other number to the 79th power. This will give us 1 plus 3 plus 5, which gives us what? 9. So our remainder for that one was a 9. So then example 4 says, given this polynomial here, x minus 2 is a factor. They want us to find the value of k. So first thing we do, set x minus 2 equal to 0. X would equal what? 2. Which again, if you can do that step in your head, that's fine. You're more than welcome to. I'm just going to keep writing it so you guys know where I get that number from, because a lot of people ask me, where's that number coming from? So if they tell us right here, x minus 2 is a factor. So since that's a factor, what should our remainder be? 0. So I'm going to set this equal to 0 and plug my 2 in for all of the x's. Now the only thing left is our k, so we can easily solve for k now. 2 cubed gives us 8. 2 squared gives us 4k. 22, and then minus 6. So 8 minus 22 minus 6, what does that give us? Let's say I got negative 20. So then we want to add our 20 over. And then divide by 4, so what does our k equal? K equals 5.